Now, we are going to look at polynomials. So, when we're talking about a polynomial, we are talking about an expression consisting of multiple parts or many terms. So right here, we are going to write that it is an expression consisting of many terms. So it is an expression consisting of many terms. And when we talk about a polynomial, we can talk about something with as few as one term or as many as however many terms we can add together. Okay, a lot. Okay, so when we talk about an example, we can have something as simple as 5. We can have 3x plus 7. We can have 4x squared minus 3x plus 6. We can have negative 5x to the 4th plus 3x to the 3rd minus 7x plus 6. Okay. It as long as it is has terms being added or subtracted together, it is considered a polynomial. Yes, ma'am.
Do the terms, like the variable, have to be the same?
No, it can be multiple different variables. Okay. Now, whenever we are dealing with polynomials, okay, for every single thing we are dealing with polynomials in this unit, your answers have to be written in standard form. Okay. So what that means is they must be written where the variables are in alphabetical order and the biggest exponent goes first, okay? So we're going to write here, must be written in alphabetical order. With highest exponent first. Okay, yes.
So, which one takes priority over the other one?
Alphabetical order, then highest exponent. Yep. Okay, so they get written in alphabetical order with the highest exponent. Okay, now we're going to actually do a few of these together, and then you are going to do a few. Okay, so we're going to go ahead, and those of you that are on y'all's computers, go ahead and put them away for me. We don't really need them today. Okay, and we are going to make sure we can write these all in standard form. When we write things in standard form, we are just rearranging it. Okay, we can do that because what is 2 plus 3?
5.
What is 3 plus 2?
5.
5. Does the order of those two things matter? No. Okay, we can rewrite anything to switch around the order, and that's what we're going to do. So whenever we rearrange it, okay, whatever the sign is in front of the number, that's the sign that's going to stay in front of the number. We just rearrange things, okay? So for number 1, we have 3x plus 1 plus 2x squared. So we only have one variable, but what is our highest exponent? 2. So that tells us that our term 2x squared gets written first because it's the highest exponent. Okay, then what term would go next? 3x. And then our constants will always go at the end. Their terms without our variables will go at the end. Okay, so all we have to do is just rearrange so that it is written with our exponents going in descending order. Okay, now for number 3. So for question 3, which term has the highest exponent? So we will rewrite this as w to the 3rd power. Which term has the next highest exponent? 5w squared. What term would go next? Negative w. Okay, then we would do plus 28. So when we rewrite this, we take the whole thing, sign and all, and just rearrange the order. That's all we're doing. All right, for number 5, we have 2 variables in this. We have A and B. Alphabetically, which one comes first? A. So we're going to start with A, and we're going to worry about A's exponents first, going from biggest to smallest, okay? So which one of those has the biggest exponents with A? So A cubed will go first. Now, which one has the next biggest exponents of A? 5a squared, b squared. Which term has the next highest exponents for A? 2ab. And then what would go next? Negative 2b to the third. Okay, so we do alphabetical order, exponents going down. Okay, so now I want you all to do questions 2, 4, and 6 for me real quick. Do questions 2, 4, and 6. What you need, Micah? Yes. Or, yeah, go ahead.
Bye. I love you. Hey, say it back. I love you.
Get a microphone. What are those things called that you put in front of your face and make sure you're in front of
Megaphone.
There, turn the back.
All right, what did y'all get for number 2?
7k plus k2 minus k plus 60.
There we go. 7k to the third power plus k squared minus k plus 64. Okay, what about for number 4?
Negative n plus n plus 24.
There we go. Okay, for 6. Okay, so alphabetical order, C first, then D. Okay, so C goes first with our biggest exponent of 3, so negative C to the third. Then we have minus C squared, D squared. Then we do plus D to the third plus 15, or 13, my bad. Constants always go at the end, okay? Constants always go at the end. They do not have a variable, so they will go last. Okay, now we're going to go ahead. Shh. Okay, we have been identifying the highest exponent when we did all of these, right? So what is the biggest exponent in question 1? 2. What is the biggest exponent in question 4?
3.
What is the biggest exponent in question 2? 3. Okay, if you are able to identify the highest exponent, you are able to identify the degree of the polynomial. So the degree of the polynomial is simply whatever the highest exponent is. So right here, we're going to put highest exponent. And the reason we want to look at that is because the degree actually tells us some things about the function. We will do less of that in Algebra 1. But in Algebra 2, you'll actually look and see how the degree affects the shape of the polynomial and what it looks like and things like that. But what we're going to do is we're going to look at how to classify polynomials, okay? So in order for us to classify polynomials, we have to know their degree and we have to know the number of terms within the polynomial, okay? A lot of these are going to be familiar, okay? When we have 0 degree, okay, it has no variable, okay? So what we're doing is we are looking at a constant when we are looking at a degree of 0. So an example of that would be if you just had 5. That's a constant. It has a degree of 0 because there is no variable in there. Okay, if we have a degree of 1, that is a linear equation. Okay, and when we have a linear equation, it could be something like 3x minus 2. Okay, our variable is no exponent. Okay, what's the understood exponent when we don't have one? 1. It's an understood one right there. That's what makes it linear. Okay, 2. If our degree is 2, it is quadratic. Okay, when we have quadratics, we are dealing with x squared. Okay, I actually want you to put a little star right there. The reason for that is quadratics are all about what our next unit is about, or actually the next 2 units is about. We will be dealing with quadratics in units 8 and units 9. Okay, so quadratics are going to become your friend, whether or not you want them to. Okay, now for number 3, okay, if you have a biggest exponent of 3, it is cubic. That means it is being raised to the 3rd power. If we have to the 4th power, it is quartic. Okay. Do not confuse quartic with quadratic. They are different. Okay. Quartic is like quarter because it's 4. Okay. Now, we could keep doing that. Like 5 is quintic. I don't remember what 6 is, but it basically keeps getting more and more ridiculous. 5 is quintic. Okay. And it goes on forever. Okay. But we will not have to classify any higher than 4 with a degree of 4. All right. That is the highest we have to classify. Now, for the number of terms, okay, if it is 1 term, it is called a monomial because mono means 1. Okay, it is 1 term, so we could have like 3x. It could be 3x squared. It could be negative 12,000 x to the 57th power. But as long as it is just 1 term, it is a monomial. Okay. If it has 2 terms, it is a binomial. Okay, and that is because bi means 2. Okay, so here we could have like 4x to the 3rd minus 3x. As long as it has 2 terms, it is a binomial. If it has 3 terms, it is a trinomial. Just like a tricycle has 3 wheels, a trinomial will have 3 terms. So we could have x squared minus 3x plus 2. And then if it has 4 or more terms, it is referred to as a polynomial because poly means many. Okay, you can use the word polynomial to describe all of these things, but when it gets to 4 or more, you can only use polynomial. Okay, whereas with 1, 2, or 3, you can use a more specific name like monomial, binomial, or trinomial. Okay, now for this next set of questions, all we're going to do is classify each one. So we're going to do 3 together, and then you're going to do 3 by yourself. So for number 7, if we have just 6, what is the degree of that? Constant. So it will be a constant, what? It is a constant monomial.
How do you say that word?
Monomial. Monomial. Yeah, monomial. Not monomial. Meow. With an L. All right. For number 9. Okay, what is number 9? It is a linear binomial.
What?
All right, then we're going to do number 12. Okay, what's the degree of number 12? 4. 4, so that means it is going to be quartic. And it has 4 terms, so that means it is a quartic. All right, I want you to take a second and do the other 3 of these. All right, now we are going to go ahead. What is number 8? It is a linear monomial, okay? Because what's the understood exponent on that x? 1. So that makes it a linear monomial. What about number 10? Quadratic trinomial. Has an exponent of 2, so it is a quadratic, and it has 3 terms, so it is a trinomial. What about number 11? It is a cubic binomial. Okay, so that is all you have to do to be able to classify them. Okay, is name that thing. Now, how many people in here know how to combine like terms? We all should know how to do that, right? And so that is all we are doing on the back of this. We are going to be adding and subtracting polynomials. So all we're doing is combining them using like terms. Okay, and operations we already know how to do. So we're going to do half of these together and half of them on our own, okay? So we're going to start with the addition example, okay? So when we look at the addition example, okay, we are adding 2 different polynomials together, okay? The first polynomial, what we are going to do is we are just going to bring down the first polynomial. It will stay the same, yes. So we have 11x minus x squared plus 13. Now, with addition, when you multiply by something by a positive, does it change the sign? No. So whenever we do this, a positive and a positive is just a positive, so 2x squared. And a positive and a negative is a negative, so it'll be negative 5x. So whenever we add, nothing in this changes. It's just the same thing being brought down, okay? Now, to combine like terms, we have to answer every single one of these in standard form. So the way I recommend you do this, okay, is you start with the term you know has to go first in standard form. So that way you don't have to do extra steps, okay? Because you could start with any of them and combine like terms, then rewrite it. But I'm trying to save you some steps, okay? So in standard form, which of these terms would have to go first? Which exponent would need to go first? 2. Okay, so our like terms with an exponent of 2 are what? Okay, negative x squared and 2x squared. Okay, those are our like terms. What is negative x squared plus 2x squared? X squared. Now, I could also put the 1 in front of it. Do I need to put the 1 in front of it? I don't have to, but you can if you want to. Okay, now, for our next term, okay, we're going to look at just the plain x. So we have, what is our like terms with x in them?
11x and negative 5x.
So 11x, negative 5x. What is 11x minus 5x? So we get plus 6x. Okay, now, does 13 have any like terms?
No.
Nope. So we just bring it down. And then this is our answer. Oh, that is not a circle. What was that? What on earth? It really wanted that to be a trapezoid, and I don't know why. It's fine. Okay, but that is how we find our answer. Okay, do y'all see how I grouped them using different symbols underneath them?
I did too.
Okay, that is a strategy you can use to help you keep up with what things you're combining, to make sure you don't forget anything, or to make sure you don't accidentally combine the wrong things. Okay, you do not have to do that. That is just something I have always done that helps keep your thinking straight. The more pieces you have in a polynomial, the more beneficial that is. Okay, if I had like 5 and 6 term polynomials, that would make it so much easier. okay, to make sure every piece was found. Now we're going to look at the subtraction example, okay? So again, when we look at subtraction, okay, we are taking two polynomials and we are subtracting, okay? So the first polynomial, nothing is changing with the first polynomial. It just comes down. So we have 4x squared plus 5x. But what happens when you multiply by something by a negative? The sign changes. So a negative and a positive make a, so we get negative 7x. A negative and a positive is going to make that negative 3x squared. And then a negative and a positive will make that negative 1. Now we're good to combine our like terms, okay? So what term should we write first to put it in standard form? Okay, x squared. So what is our like terms with x squared? 4x squared and negative 3x squared. What is 4x squared minus 3x squared? Okay, what is our next set of like terms? Okay, so 5x, negative 7x. What is 5x minus 7x? Okay, what is our last like term? Does it have any friends? No, it's lonely. That was mean. All right, so that right there is our answer, okay? So I know we are going through this really slowly, but that is just because I want to make sure we have it, okay? So that we don't accidentally mess up, okay? Now, we're going to do all of the evens together back here, I do believe. Yeah. So let's look at 14. So for question 14, am I adding or subtracting those two polynomials? Adding, okay? So the first polynomial, we just bring it down. So we get k squared minus 4k plus 7. Now, whenever we add, do we change signs? No. So a positive and a positive is still positive. A positive and a positive is still positive. Positive and a negative is negative. Now, what term should we combine first? So what is our like terms? What is k squared plus k squared? So we have 2k squared. Now, what should we combine next? Okay, what is negative 4k plus 9k? Then what should we combine last? 7 and negative 3. What is 7 minus 3? So that is our answer. For number 16, are we adding or subtracting? Okay, so does anything change with that first polynomial? Nope. So we bring it down. And then when we add, do we change signs? No. So positive and a positive is still positive. Still positive. But a positive and a negative is, okay, so from here, what term needs to go first? X. So what are my like terms? What is 9x plus 3x? Okay. What term needs to go after that? Does negative 5y have any like terms? Nope. So it just gets brought down. All right. What needs to go last? How did you get 20? 20. 27 minus 7 is positive 20. So that is our answer. So I want y'all to go ahead and do question 18 for me real fast. What'd y'all get for the answer?
9a squared minus 9a.
9a squared minus 9a. Okay, because 6a to the second power plus 3a to the second power is 9a to the second power. And then we have negative 5a plus 1a. So we have negative 4 plus 5, or minus 5, which is negative 9. Okay, now we're going to go ahead and we're going to look at questions 20, 22, and 24 as well. So for question 20, am I adding or subtracting? Subtracting. Now, will this first polynomial do anything different?
No.
We just bring it down. So 5r minus 2s. From here, will my signs change?
Yes.
Because a negative and a positive is,
Negative.
and a negative is positive. Now, alphabetically, which one needs to go first, R or S?
R.
R. Okay.
I just sing the whole alphabet.
That's okay. So that's our first term. Now, what goes next?
S.
Okay, what are our like terms with S?
Negative 2 is 11.
What is negative 2s plus 11s? Plus 9s. And then what's our last term? And does that have any like terms? So there we go. All right, now let's look at number 22. Okay, for question 22, okay, does anything happen with this first polynomial? So we bring it down. So 3m squared plus 7m minus 1. Are we adding or subtracting? And what happens when we subtract? So a positive and a negative make a negative and a positive make a, but a negative and a negative make a. What term goes first?
3m squared.
Okay,
And m squared.
so our like terms are 3m squared and negative m squared. If we combine those, what do we get?
2m squared.
2m squared. Okay, what would our next term be?
Negative 2m.
What does it have any like terms?
7. Oh, I can.
So what is 7m minus 2m?
5m.
And then what is our last terms we need to combine?
4. I mean, negative 1 and
Negative 1 plus 5, which gives us plus 4. Okay. Now, just for funsies, if I wanted to classify this polynomial, what would I classify it as?
trinomial. No.
Mm-hmm.
Oh, yeah, it is a trinomial.
It is a trinomial.
And the 2 is quadratic.
It is a quadratic trinomial. All right, do 24 for me real quick. What term needs to go first? Okay. So 8x minus 5x gives you, okay, what do I need to combine to get the next term? Which is, okay. Is there anything I can combine with 13?
No.
So we just do plus 13. All right. So what I want y'all to do for the next few minutes is I want y'all to do the odds right next to those. Okay? I want you to go through and do the odds questions 13 through 23. And I do not know why that 0, 0 is there. I'm sorry. I don't know where it came from. I don't know what I was doing.
It's really inconvenient.
I'm so sorry. I did not mean to put it there. Yes, what you need?
No, I just wanted to like some.
Okay. Okay, give me just a second.
Are you like say that right now or no? Not yet. No.